Welcome back to geometry. We're going to do section 4.5 using congruent triangles, which is really just more can we prove it, and also we're going to learn a little bit more about extra things we can prove. Sounds fun, right? Okay, so to start with, I have these two triangles. First of all, can I prove that they are congruent? I've got these two sides are the same and those two sides are the same, and because of reflexive property, there's my mirror holding it up to you. I know, oops, I should use the red one. Red's the color you're supposed to use with this. That equals itself, so I know by side, side, side that these two triangles are the same. Now, because I know that, I know more things too. I know that this angle equals that one because of this thing called congruent parts of congruent triangles are congruent. Of course, I say congruent. Corresponding parts of congruent triangles are congruent. See, these are the same angle on these triangles, so those are, we know, and we could prove that if we needed to, that those two angles are the same. We could also prove, we could say that these two angles are the same because corresponding parts of congruent triangles are congruent. And how you abbreviate that is you write core parts of congruent triangles are congruent. That's how it gets abbreviated, all right? Because, you know, we're all cool and nerdy and we don't like to write too much, all right? So, and then we can also say that that angle equals that angle, okay? How about this one? Here we've got these two lines are parallel and those two lines are parallel, and we have this transversal, which makes two triangles. Can we prove line AB is congruent to CD? We can, because we can prove these triangles are the same, and then we can use corresponding parts of congruent triangles are congruent. So we know first of all that this is reflexive and congruent to itself, and we know that this angle is congruent to that one because of alternate interior angles. If you have parallel lines cut by a transversal, alternate interior angles are congruent. And we know that this angle equals that one, or is congruent to that one, because of alternate interior angles. So now, by angle, side, angle, we know the triangles are the same. And if the triangles are the same, we can say that those are the same because corresponding parts of congruent triangles are congruent. Ta-da! All right, let's try another one. A is the midpoint of that line and that line. Can we prove that these two lines are parallel? I think we can. So let's think about what do we know since it's the midpoint. Well, we know this line equals that one and that line equals that one. What else do we know? Chink! Vertical angles. We know that this angle equals that one. So we have side, angle, side. Proving that these two triangles are the same. And corresponding parts of congruent triangles are congruent. So we know this one equals that one. And we know, but that's not what's so important. What we know is that this angle equals that one because they correspond. And that means that these lines have to be parallel because when they're cut by a transversal, they made congruent angles. So this is called alternate interior angles converse. It means we're going backwards. Because these are the same, we know that they're alternate interior angles going between parallel lines, and therefore we can prove that the lines are parallel. Now what I want you to do is be sure to read each of these proofs carefully in the book, but I'm talking you through them, but read them and make sure you see it yourself too. Okay, how about this one? Can we prove that triangle BCE, that little triangle, is congruent to this little triangle? Well, how we're going to do it is by using the whole shape. And we're going to prove that this big triangle equals that big triangle. And then we can use corresponding parts of congruent triangles are congruent. So let's think about what we know here. They told us that angle 1 is congruent to 2 and 3 is to 4. And those are the angles of this big triangle. And don't you see, because of reflexive, that this line CA is equal to the line CA. So we have angle, side, angle. And we can prove that those two big triangles are congruent. Once we do that, we can also say that this line equals that one because corresponding parts of congruent triangles are congruent. And then we could say that this line CE, equals itself because of reflexive property. And then we have side, angle, side, side, angle, side. So we can prove those two little triangles are congruent by side, angle, side. I think they're kind of fun. When I was your age learning it, I remember it seeming like a great big mystery. But the more you do it, the easier it gets. And it starts to get fun, especially with the triangles. All right? So read the chapter carefully, study the examples, and then you're going to get better. The more you practice, the better you're going to get at writing proofs. All right? Math is great. See you next time.